Hi class, we continue our study in statistics by talking about measures of central tendency. And so what measures of central tendency try to do in statistics is they try to describe what a typical data value looks like, a way to summarize a typical value in just one number. So we have four objectives in this class. We're going to talk about how you determine the mean of a data set, the median for a data set, the mode for a data set, so the mean, median, and mode. And then the final thing we'll talk about is something called the mid-range for a data set. All right, so what is the mean? So we've probably all taken a mean before. It's like an average of some type. Okay, you definitely have done this. So all it is the sum of the data items divided by the total number of data items. Okay, so the mean for a data set. In mathematics, this notation here is actually a capital sigma, Greek letter sigma, and it just means sum up the x values, and then we're going to divide by n, and n is going to represent the total number of items. Okay, so sum them up, divide by the totals. Whenever you see n, that's just the number of items in the data set. Now let's do an example. All right, so question is, are investors born or made? So it would be nice to think we could all be great inventors, but history says otherwise. So based on a sample of adults, let's say in 10 selected countries, shows wide agreement. So this is a sample of 10 countries: China, Singapore, Russia, South Africa, UK, Australia, India, Mexico, us, and Brazil, us, the United States. And what this is they're asking people, can being an inventor or inventiveness be learned, or is it inherited? All right, so what we want to do is we want to find the mean percentage of adults in the 10 countries who agree that inventiveness can be learned. So we want to find the mean of these 10 values here. So find the mean by adding the percents of the 10 countries and dividing by this sum, okay, this sum by the number 10, which is the number of data items. So we use this x bar here, this x with a little bar over it, okay? This x bar, when you see this, what it represents is a sample mean. So that's equal to the sum of the x values divided by n. Well, the x values are the percentages of the 10 different countries. If you were to sum these percentages up, you would get 799. You divide that by 10 because there's 10 countries. And we'd say the average percent of people who think inventiveness can be learned from these 10 countries is 79.9%. So just sum them up. That's all you have to do, sum them up and then divide by how many there are. All right, so let's go back and talk about now when you have a frequency distribution. Okay, so when many data values occur more than once, all right, and a frequency distribution is used to organize the data. So we talked about frequency distributions in the previous lecture. We can use the following formula to calculate the mean of them. So the mean, which we denote as x with a bar over it, call x bar, is equal to the sum. You're going to take each x value, multiply by its frequency, so the number of times it occurs, divide that by the total number of frequency or total counts in the distribution. Okay, so the sum of each x value multiplied by its frequency or count divided by the total count of values. All right, so let's do an example. So the table on the right shows students' responses to the question, how stressed have you felt in the last 2.5 weeks on a scale of 0 to 10, with 0 being not stressed at all and 10 being as stressed as possible. So use the frequency distribution to find the mean of the stress level ratings. So basically this is what we're saying. We gave this survey to, it's going to look like 151 students. Okay, if you sum up all these frequencies, it sums up to 151 students. And 2 of the students said I wasn't stressed, 1 student said I had a stress level of 1, and so on, all the way to 14 out of the 151 said, yes, I have a stress level of 10. I'm as stressed as possible. All right, so the solution. Okay, so how to find the mean of this, so the mean stress level. First thing you're going to do is you're going to find this x times f. Okay, so it helps to put another column here. And all you're going to do is you're going to take each x value multiplied by its frequency. So the 0 rating times 2, the 1 times the 1, the 2 times the 3, so on. 3 times 12, 4 times 16, 5 times 18, 6 times 13, 7 times 31, 8 times 26, 9 times 15, and 10 times 14. You're going to multiply all those and get these numbers here. Okay, so all you've done is taken each x value multiplied by its frequency or count. Now what you need to do is you need to sum them up. Okay, this summation sign tells me to sum up all these values. So if you were to take this plus this plus this plus this and so on, all these values here would sum up to 975. So then the mean of this average, or the sample mean of this frequency distribution, it's the sum of the x times the frequencies, which is 975, divided by n, the total number of observations or data values, which is the sum of the frequencies, which is 151. So if you took 975, divided it by 151, the average stress level for these students would be 6.46. So unfortunately, it does seem like these students are a little stressed out. All right, what is the median next? Okay, so we've talked about the mean. Now let's do the median. So the mean is the data item in the middle of a data set. Okay, all right, this data set, to find the median, has to be ranked or ordered, so it's the middle value. So to find the median, if you can do this by hand, of a group of data items, first thing you do is arrange the data items in order, smallest to largest. If the number of data items is odd, the median is the data value right in the middle, so that's easy. But if the number of data items is even, this one gets a little bit harder. The median is the mean of the middle two data items. Okay, so if there's an even number of items, there's a little bit of an extra step. All right, let's do this one. All right, let's find the median for each of the following groups of data. So for this first one here, I have the values 84, 90, 98, 95, and 88. All right, so there's 5 data values. Okay, so the median is going to occur in the middle of this. So you're going to arrange the data items in order from smallest to largest. So if you do, see, this is in order now, 84, 88, 90, 95, 98. You can very easily see that this number here falls in the middle. All right, so the median here is 90. Okay, there's another way to do this. You can go to find the median in what's called the n+1 divided by 2 position. So n is the number of observations. So 5 plus 1 is 6, divided by 2 is 3, and the median is in position 3. So here's position 1, position 2, here's position 3, which is also the median. Let's do this one here. So I've got find the median of all these data values, 68, 74, all the way to 47. So the first thing you're going to do is you're going to arrange the values from smallest to largest. Okay, so the number in the list here is 10, so it's an even number. So what you're going to do is you're going to find the middle two numbers. So there's a couple ways you could identify the middle two numbers. You can cross off values in unison on the end of each other, like I'm doing with my mouse here. And then you get these two middle ones. Or you can do that n+1 divided by 2 position. So there's 10 plus 1 is 11 divided by 2. The median occurs in position 5.5. Position 1, 2, 3, 4. Here's position 5. Here's position 6. The median must be in the middle then of these two numbers. So then the median is just the average of these. So take 28 plus 34. That gets you 62 divided by 2. The median here is 31. All right, so another one here, this is talking about the n+1 divided by 2 position. Like I said, find the median of the letters of the 9 longest words. Okay, so suppose listed below are the number of letters in the 9 longest words in the English dictionary. So here's the data values. Okay, they're already ordered. So the median occurs in position n+1 divided by 2. Well, 9 plus 1 is 10, divided by 2 is 5. Position 1, position 2, position 3, position 4. Here's position 5. So the median of this data set obviously is 20. You can also find the median of a frequency distribution as well. Okay, so the way you would do this, so if there are 51 data items in this table, so we go back to the stress level one. The median is the value in the n+1 divided by 2 position. Remember that, n+1 divided by 2 position. So take 51 plus 1, because that 51 is n, the number of observations. 51 plus 1 gets me 152. Divide that by 2, that means that the median is going to be in the 76th position. So all you're going to do is you're going to count down the frequency column and distribution until we identify the 76th item. Well, so 1, 2, then this is the third item, 4, 5, sixth item, then I'm going to add 12 here to get to 18. You're going to keep going. Next, I'm going to add 16 items, then 18 items, then 13, and then when I finally get to this 7 row here, and I start adding to get 31 data values, I find the number 76. So we've stopped counting, so we've reached the 76th data item. So the 76th data item is the number 7. So the median stress level of students then is 7. That's the median. All right, let's talk about comparing the median and the mean here. All right, you can see some subtle differences. So 5 employees in a manufacturing plant earn the following salaries. 19,700, 20,400, 21,500, 22,600, 2,300, or 23,000, excuse me, and 95,000. All right, let's find the median annual salary for these 6 people. Okay, so the employees and then the manager. So if you were to arrange this data, okay, since there's an even number of data items, the median is the average of the middle 2. Well, 21,500 and 22,600 are the middle 2 data values. So if you find the average of those two, we're saying that the median salary is $22,050. All right, but if you were to find the mean now, well, the mean is just adding them all up and dividing by how many there are. Well, if you add up all the salaries and divide by 6, you see that the mean, well, look at this. The median was $22,050, but the mean here, because of this one manager is making a lot of money, is $33,700. All right, so the important thing here is the median does a better job, accurately predicting what a typical person at this plant makes, whereas the mean is skewed because of this high salary up here. Let's talk about the mode. So the mode is the data value that occurs the most often in a data set. So if more than one value has the highest frequency, each of these data values is the mode. If there is no data value that occurs most often, okay, then we can say that there is no mode. So if you look at this, right, this is actually pretty easy. Find the mode of this following group of data: 7, 2, 4, 7, 8, and 10. Well, you can just quickly look at it and see that the number that occurs the most is 7. So here the mode is 7 for this. All right, let's end talking now about the mid-range. So the formula for the mid-range is found by adding the lowest and highest data values and dividing the sum by 2. Okay, so the mid-range formula is just lowest value plus the highest value in a data set cut in half, divided by 2. So Newsweek magazine examined factors that affect women's lives, including justice, health, education, economics, and politics. Using these 5 factors, the magazine graded each of the 165 countries on a scale from 0 to 100. The 12 best places to be a woman and the 12 worst places to be a woman are shown in the next table. So find the mid-range among the 12 best countries to be a woman. All right, so here are listed as the best places to be a woman, and here are the places that are listed the worst to be a woman. So we want the mid-range of the best. So it's the lowest score, which was 87.2, plus the highest score in Iceland, which is 100. So 87.2 plus 100 divided by 2. Well, that means the mid-range of the 12 best places was 93.6 as a score. All right, class, thanks for watching the lecture.